All right, today we're doing graphs of functions. This is actually not a difficult section. It's analyzing the domain and the range of functions. And this is a mixture of your notes and your homework. So I'm going to do an example, and then the next set are your homework. So look at these first 4 questions. Here's your picture. This defines your function right here. Now, in case it's very difficult to see this, but this is a closed circle here, this is an open circle, this is an open circle, and that's a closed circle. So what is graphed defines the function. So if I ask you, what is f of 0? They're asking you, this 0 is your x value. When you plug 0 in for x, what's your output? Your input is 0. Now you're going to go to the graph, and what is the number that comes out? 7. That's a 7. 5, 6, 7. So the answer to f of 0 is 7. What about f of 3? You're going to go to 3 on the x-axis. And what's f of 3? 0. Now, how do you write the domain of this function? The domain is the x values from left to right. So we want to read, what is the smallest x value in this set? What's the smallest x value? What is this number right there? -8. And it goes to what?
2. Oh.
To what? It goes to 2, and it's skipping over 2, because we have 2 open circles. So you're going to write your domain in interval notation like this. It begins at -8 with a bracket, because it's including -8. See, that's a closed circle. Then it goes to the number 2, and we're skipping over 2, because these are both open circles. And then we're going to continue on with 2, and we're going to go to what x value? What's the
7.
x value here? It's like 7. Now, should we put a bracket with 7 or a parenthesis? A bracket, good job. That's your domain. Now, if one of these circles right here were closed, if one of them were closed, how would you write the domain? You would write -8 with a bracket, comma 7 with a bracket. You don't need to skip. You don't have to do this part right here, because there's no break. Now, can you tell me what the range is? What's the smallest y value in this set? What's this y value right here? Right here.
-9.
-9. So we're going to use a bracket because it's including it. And then this picture, it includes all the y values all the way up to what number? 8. And you're going to do comma 8. Okay, so these are going to be the easiest problems in your test. Evaluating these functions, and then the domain and the range should be pretty simple. So for homework, you're going to do these 2, which are evaluating, these 4 are evaluating this picture, and these 4 are in reference to this picture. Okay, so go to example 2. How do you determine whether a graph is a function? Do you remember the vertical line test? If you can draw a vertical line through the graph and it hits in one spot, it's a function. If it hits in 2 spots, it's not a function, because then you're giving the, like, for example, if you look at this right here. This is hitting in 2 spots. This is 4, comma 2, and this is 4, -2. So see how the 4 is repeated? That's not a function. So this one is not a function, no. But this one, is this one a function? If you draw a vertical line through this as many times as you want, you're only going to hit it in one spot. So that one is a function. So that's going to be an easy question on your test as well. Determining whether a graph is a function based on the vertical line test. Everyone's cool with that? So 9 through 14 for homework, you're gonna say yes or no, which ones are functions, which ones are not. You can save that for when I give you free time today. Okay, now, yesterday you were given a piecewise function. Yesterday, you were asked to do this. So if I give you this, f of x equals x squared if x is less than or equal to 1, and then x plus 2 if x is less than or equal to 4 or greater than 1. So what we did yesterday was this. If I said what's f of 3, or what's f of -1, how do you do these problems? This is your domain right here. Where does 3 fall? Is 3 a number less than 1, less than or equal to 1? Or is it between 4 and 1, including 4, not including 1? Which one of these two does it fall in? The second one. So you're gonna put 3 right here and do 3 plus 2, which is 5, right? Now this one, -1 is in this category, so -1 squared is 1, right? That's how you would do that. But in today's assignment, you have to graph this piecewise function. There's 2 ways to do it. The way that you probably are going to want to do is the T-chart method. Okay? So, how do you do the T-chart method? Well, check this out. We're going to do y equals x squared. Look at this right here. Y equals x squared. For the x values, you only want the x values that are less than or equal to 1. Tell me the numbers that are less than or equal to 1. 1, 0, -1, -2, -3, and so on. Why am I not putting 2, 3, 4, 5, 6, 7? Because they're not less than 1. So now plug these numbers into this function. What is 1 squared? What is 0 squared? What is -1 squared? And -2 squared? And -3 squared? Now plot these points. Over 1 up 1. 0, 0. Over 2 up 4. And over 3, 4, 5, 6, 7, 8. Now, what does a quadratic look like? It looks like a U. So make this look like a U. Now, what should I do with these two? This one has an arrow because it's saying less than 1, so it continues on. So we have an arrow here. But what should I put here? Should I put a closed circle or an open circle? Closed. Why? Because it says less than or equal to 1, and it was equal to right there. Okay? The second function says y equals x plus 2. But what numbers do we want to plug into our T-chart? We're going to start with 1, but when we evaluate it, we're going to put an open circle there because there's no bar there. 1, 2, 3, and 4, and we're going to stop. Okay?
But don't we not put 1 because it asks only numbers bigger than 1?
Yes, but you're going to do it so that way you can put an open circle there. So what is 1 plus 2? 3. What's 2 plus 2? 4. 3 plus 2 is 5 and 6. So we're going to go over 1 and up 3. 1, 2, 3. And right here, we're going to do an open circle, not closed. This one has a closed circle. We want this to be a function. And then we're going to go over 2 and up 1, 2, 3, 4. and over 3 up 5 and 6. Now 4, 6. So this is what you're you want to connect the dots here because it's a line. This is what you have. You have an open circle at 1, 3 and a closed circle at 4, 6. That is the graph of this piecewise function. Do you get this? You're just going to have to make a T-chart and plug only the numbers that correspond to that function, okay? So for homework, there are 3 of them that you can do. I did not draw in a T-chart, so you might want to just make a little T-chart. I left you some room. The other way, I told you there was another way you could do it. What you could do is you could graph y equals x squared. Where is y equals x squared? So here's another way you could have done it. So y equals x squared is a parabola. It's over 1 up 1, over 2 up 1, 2, 3, 4, and so forth. Over 3 up 9. You can draw your parabola like that. And then just take an eraser. You only want the x values that are less than 1. So you go to 1 on your graph and you just erase all this if you want, if that is easier for you. I don't mind. So you could do it that way. And then where is the line y equals x plus 2? It begins at 2 and it goes up 1 and over 1 like this. It's this line right here. But I only want the x values that are greater than 1, so I go to 1 and I erase all this. Okay, and it says less than 4, so go to that and erase that, and then I just draw my closed circle and my open circle there. So if you want to do it that way, I don't care. So it's up to you. If you want to make a T-chart and plug only those specific numbers to that function, awesome. If not, I understand. Okay, next and last, I believe this is it. These are called, let's review, how to graph an absolute value function. Do you guys remember what an absolute value function looks like? What's the shape of an absolute value graph? Is it a circle? Is it a square? Is it a U?
It's a V.
What is it, Teddy?
It's a V.
It's a V. Do you remember all the transformations of it? Do you remember how to graph an absolute value? So if I said, how do you graph absolute value of x plus 3? What if I said graph y equals absolute value of x plus 3? What if I said graph absolute value of x minus 2? What if I said graph y equals absolute value of x minus 2? What do these things look like? You gotta know where they're going. You know what this one is? Where is this one? It shifted 3 units to the left. And then it goes up 1 and over 1. Remember where this one is? Up 3, good. 1, 2, 3, just like that. Remember where this one is? 2 units, right. And do you remember where this one is? 2 units down. So you need to know that. Okay. Now what you need to realize is that an absolute value is an actual piecewise function. It is actually 2 lines. So if you were to extend these, it's 2 lines. So let's take a look. We're going to do these 2 together. Actually these 4 together. 45, 46, 47, or actually 45, 46, 48, and 49. These are the hardest ones. So what I want you to do, I want you to graph this function right now. Where is y equals absolute value of x plus 2? Where is it? Well, it begins right here at 2, and it goes up 1 and over 1. Okay, does everybody understand that? Now, I am going to extend both of these so that they're actual lines. So can you give me, we have 2 lines here. Here is one line. Let's go with the positive line first. If I extended this, can you tell me the equation of this line right here? Right here. What is the equation of that line right there? What is it? Y equals what? Where does it begin?
2.
At 2. And what's the slope? Positive 1. Right? Now, if we're not using this part, we're taking this line, we're saying we're going to use this line, but to create this absolute value, we only want the x values that are, this part, greater than or equal to 0. Because this is your x value. You go by your x value 0. Then look at the other line that we've created here. If we extended this, keep going down the other way. What's the equation of this line right here? This is the line y equals, it's a negative slope, and it begins at 2. But this line, we only want this piece for the x values that are less than 0. Do not put a bar. These are both going to be the same number right here. One is going to have the bar and one is not. You don't want to include the bar in both spots, just in one. So now, how will you write this as an absolute value? All you need to do is take these y's out, make a bracket like this, and just write f of x. And that's it. So you've turned this absolute value function into 2 lines with restrictions. Do another one. Okay, I want you to graph absolute value of x minus 4, 4 units down. So where is that one? 4 units down. It's 4 down, and it goes up. I need the equation of both of these lines. One is a positive slope and one is a negative slope. Let's do the positive slope line first. What is, if you extended this, what is the equation of this first line right here? Right here. Can I get the equation right here? X what? It's y equals, what is it? What kind of x? Positive x. And then what? Minus 4. And the restriction is for the x values that are greater than or equal to 0, because this is going that way, positive. So greater than or equal to 0. Then I need the equation of this line right here. This is going to begin at negative 4, but it's a negative slope. And I want that for x is less than 0, because these are all the numbers less than 0. And you're done. Just make your little erase. You don't need the y equals twice. You're making this one problem by doing that bracket, and you write f of x equals. Okay, so if it's shifted up and down, these numbers are going to be zeros. These ones are different, these next two. Where is the absolute value of x plus 3? Isn't it shifted 3 units left? Thanks, Mike. 3 units left. 1, 2, 3. And you're going to go up 1 and over 1. So that's that line right there. And then here's the other one. Okay, so I'm going to cover this up right here. I want the equation of this line right here. What is the equation of this line? y equals what? Begins at 3, and it goes up 1 over 1. So it's x plus 3. You agree with that? Okay, but I want to use this line for the x values that are, where's this x value right here? What number is that? It's not at 0 anymore, it's at -3. So I'm going to say greater than or equal to -3. Got it? Now let's do the other line right here. So here it is right here. If you extended it, can I have the equation of this line right here? What's the equation of this line right here? Negative x, I heard. Huh? 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 Yeah. I wasn't, I was just getting you to change your mind. So it's -3. Because see this line? It's going down, it's hitting at -3. But its x is less than -3. It's only the numbers from -3 on. Does that make sense? So I only draw that to see where it hits. There's a trick you can do too. I can show you, but I want you to understand where these numbers are coming from. I could show you the trick, but then I'm just scared you're just gonna memorize and then forget. Okay, next one. So let's see if you can do this one. Tell me where this graph is. Anyone know? Where is absolute value of x minus 5? It's 5 units to the right. Anyone think they know what this piecewise is? F of x equals. You know what one of the equations is? X plus 5. Say it again, Lexi, you said it. See this line right here? This is going down here to -5, and it's a positive slope. So this one's gonna be x minus 5. And you're gonna use this line, this is the line x minus 5, because it begins at -5. 1, 2, 3, 4, it's, I went a little crooked. It's here, okay? This is the line y equals x minus 5. It's a positive slope. But you want that for the x values greater than or equal to 5. And then what's the other equation? What's this equation? It's negative x plus 5. And you want that for x is less than 5. I think you said, did you say x minus 5?
No, I said plus 5, but I was talking about the other one.
Yeah, I think you had the slope wrong then, right?
Yeah.
Yeah.
I forgot the number.
Yeah, that's what you gotta watch. You'll lose a point for that. So we just did 4 of your homework problems. So you have the rest of the time to work on the homework. You should get it done before you leave. It's not difficult. And, John, can you stop recording? You done?
Teddy,
Ready?
thank you.
Thank you. So the rest